Okay, graphing polynomials in factored form is a huge part of algebra. It leads up to something called the fundamental theorem of algebra. Today we're just going to focus on factored form, and we're going to talk about a lot of different examples in where when they give you factored form, we're just going to be able to graph it using intercepts. So, let's start with this. Now, we had these before. This was actually, you would have seen this a unit or a week ago, where it wasn't factored already for you. And so, it would look like this. You would factor it, and then you would use intercepts. So, it's not going to be any different. If they give you factored form, just know that this is going to be 1, 0 and negative 4, 0 from the zero product property. And if we expand it out, this is going to be our y-intercept, 0, negative 4. So to graph this, I go back 1, 2, 3, 4, and forward 1. And I'm going to go down 1, 2, 3, 4 for my y-intercept. I know that my parabola is going to look something like this. So when you do this, here are the things that we're going to do. We're always going to find our intercepts. We're always going to find our y-intercept. We're actually going to even expand it out into this, and then we're going to graph. One thing you should know that this is called standard form, and this is factored. So for today, we're going to start in factored, go this way, and do everything in that direction. But there will be times when we want to go backwards to factored from standard, which you've done before, but it gets a little hairy when we have like cubics and quartics and quintics and more complicated things. So I just want to talk about two other quadratics that we didn't talk too much about, like this one. So we would know that this is 1, 0 for an x-intercept, but that x in front sometimes confuses people. This is, you could think of it like an x minus 0 in front. We just don't write that minus 0 part, so we leave an x. That means that your x-intercept is 0, 0. Now, if you take this and expand it out and write it in standard form, if you drop your x in, you would have this. And now, if you look at the last number here, there's nothing there. So your y-intercept is 0, 0. When people go to graph this is sometimes confusing because 0, 0 and 1, 0, well, there's no third point to know whether it should be going down and up like this, or going up or down like this. And this might happen when you're doing polynomials. So one other thing you could look at is the lead term. Now, the lead term, if it is positive, you know that it's going to be smiling. So in this case, it's going to look like this. Okay. Okay, and then another example that is a little strange. Now in this case, the x and the 1 are flipped around. So when you're thinking about x-intercepts, remember, it's not just the opposite. What you're thinking in your head is x plus 2, when is it equal to 0? Well, that's if I subtract 2 on both sides, I'll have negative 2. So we quickly just write down negative 2, 0. But for this one here, 1 minus x equals 0. If I subtract 1 on both sides, I have a negative x equals negative 1, which means x is actually positive 1. So it would be 1, 0. And so when they flip it around, it could be a little, some people might be tricked into thinking that's negative 1, but it's really positive 1. And then when we expand this out, we we have to do foiling. So I'm going to multiply those two together. That would be x plus 2, and that would be negative x squared and negative 2x. Writing that in standard form, we have negative x squared, we would have negative 1x, and then plus 2. That's my standard form. Also then, my y-intercept is 0, 2. So I have the 3 points, and I have 1, 0, and negative 2, 0. Now you notice the shape of this requires that we have a frowning parabola. And I wanted to show you this one also because when you expand it out, that negative means that it is frowning. The leading term, it's called at the front, is negative, so it's going to be frowning. Alright. Let me just get rid of this here. Now we're going to start to make this a little more exciting because we are going to be, instead of writing just 2 of those parentheses, we're going to write 3. Okay, now this is going to be a cubic. It has 3 different factors here. These rooms are called factors. And we're going to have negative 1, 0 be an intercept, 3, 0 be an intercept, and also 5, 0. Excuse me. So my graph here, negative 1, so there's 2 ways that this could happen. Let me draw both of these. One could be it going up like this, coming down, and then going up. That's one possible way to graph it. And the other would be going down, coming up, and going down. So the main way we determine which way it's going to go is by expanding. So first, I'm going to take the first 2 factors and expand that out. Now after you expand that, you're going to get x squared minus 2x minus 3. If you work that out and FOIL that out. And then I still need to include the last term that we haven't worked out yet. And now remember that one of the easier ways to do this, to then expand a 3 by 2 out, is to organize it with a box. So I'll put x at minus 5, that'll be x cubed, and minus 5x squared plus 10x plus 15. If I combine those all out, I get x cubed minus 7x squared plus 7x plus 15. So that is my standard. Now there's 2 ways to tell which of these snakes is going to be correct. Well, first of all, my y-intercept is going to be 0, 15. So I know right away this is going to be 15 up, and so it must be the green one. But also, something that the lead coefficient tells us is if it's positive, then it goes up. But with a cubic, it's not as easy as a quadratic. Because the cubic goes in this direction down and this direction up, and vice versa. So when it goes up like this, what it means is to the right. It's kind of like the slope. Now the green one kind of has a positive slope like that. The red one, though, would have a negative slope, so we're not going to include that one. So let me erase here the red line, because that's the one that wouldn't work here. And that is the graph of our cubic. Okay, so we're going to do another one of these. Still 3 factors, so it's still going to be a cubic. This one is going to be a little different. When we write out our x-intercepts, you have negative 2, 0, we have 3, 0, and we have 3, 0. Okay, so you might see already why this one's going to be a little strange. Because we have a double root. 3, 0 and 3, 0 are the same. But that's okay. We still put the point there. And what that means is often I will put a box around it because if you remember with quadratics, when we had a double root, it would bounce off this way or like that way at that one point. So in this case, we're going to either come up and bounce off, or we're going to come down and then bounce downward. So we have to figure out by expanding which direction that will be. Alright, I'm going to expand these two first because I know that's going to be x squared minus 6x plus 9 if you FOIL it out. Alright. Here's my expanded form. Now in this case, we know that the y-intercept is going to be 0, 18. So I'm going to put it up here. That's my y-intercept, which means it must be coming from the y-intercept, come down to the point, but then bounce off the point like this. That also means that going back, I have to be going down through that last point. This also makes sense because the lead is positive, which means that our slope should be positive, kind of, for this curve. Okay. Now, there's one more that I wanted to talk about very quickly. We could do even better by creating 4 factors. And what this amounts to is that when we are graphing it, we'll have -1, +1, and we'll have -2, 3, 4, and 5. So, we're going to have 4 points, and then we're going to have a y-intercept, and it will either be going like this in a W, or possibly it could be going like this, like an M. And so I'm going to stop before actually going through all of it, the rest of it. All I'm going to say is that when you're expanding this out, expand out this, and then expand out this. Whatever you end up with those two answers, then you multiply them and keep going. So it's going to be even, it's going to take a little more work than a cubic, but just take it 2 at a time, and then take those answers and multiply. Now, based on your y-intercept and your lead coefficient, you should be able to tell, is it a W or is it an